my object in this presentation is to show how the 6 planets that orbit around the sun, from Mercury to Saturn, are an expression of rational thought. Now, before I continue, let me just justify the politics of this work. There's a story that I like in particular from the book of Judges in the Old Testament. And it's the story of Deborah the prophetess. And if you're not familiar with, this is a time generations after Moses and Joshua brought people from the bondage of Egypt into the so-called promised land of the Canaanites, where they were free and independent. But consistently, they continued to fall under oppression by kings, other types of savages, barbarianism, and so forth. And there's no separation of economic oppression from any form of oppression. It's precisely that. It's slavery, exploitation of man, exploitation of resources and materials. And so, Deborah is a prophetess who leads a war to allow the freedom of the people. I guess Israel in this case is not the crazy Israels of today, but then, as it was back then. Now, she says something very interesting that I think is important to reflect on. And as she's giving her sermon or her speech after they defeated the king of Canaanite that oppressed the Israeli people, which happened in numbers of times that you'll read if you ever get a chance to read this particular book. She mentions that the stars waged war from the heavens, and that was on the side of mankind. Now that's interesting as a poetic idea, but then also juxtapose the other point that I was saying, which is why, after they had the so-called, right, in the story, the hand of God brought them out of the bondage of Egypt, away from the oppression of Pharaoh, why did these people consistently fall under more oppression? Generation after generation after generation after generation. And I read that first maybe about 8 years ago, and it always hit my mind as a dissonance. And it wasn't only until recently that it really hit me the great insight that anybody can get from this. And it's that the source of corruption, the source of oppressors, the power to oppress, the source is from the corruption of the people themselves. It's when the people don't pursue their actual creative powers. And the power of creativity, the power of the imagination, is the power to define the future. It's not just, yes, the forecast of the future. You can see conditions where it would lead to if we continue on a certain trajectory, a certain pathway. But the real power of mankind is to envision in his mind, in the matter of his mind, before it actually exists in the actual world, what world he wants, what world he wishes to create. And that, I think, really turns into what I want to highlight with the importance of this work. Because it may seem as it belongs nowhere in the domain of politics. And I argue it indeed belongs everywhere in the domain of politics. And it's because we have a generation currently that does not just the specific work, but the intention to drive for what is man in the universe. That big black thing with the white dots outside that you see out there. You tell me you don't wonder about what's out there? You tell me you don't wonder about what is this massive ocean that we call space? And here we are, these little beings in terms of size and material, and we are here, and we brought fire, and we domesticated the beasts, right? We learned how to harvest crops greater than nature itself can do. And then we can wonder about something out there, even though we don't know it in detail. Just that. What creature on planet Earth can do that? Wonder, question, why? What is it? And it's the desire, it's that very question that burns in people like a passion, and to pursue discovery. And it's been to the extent that civilization had been committed to that personality themselves, which is innate, it's inherent, that we succeeded. In the United States, what made us the pinnacle of hope was not just some vague reference of liberty or some ambiguous idea of freedom. But that freedom was, as it states in the Declaration of Independence, right? The inalienable right to life, liberty, and the pursuit of happiness. And it's committed to the idea that you know what in modern ages, how that is expressed. And clearly what we're saying today about Glass-Steagall, the idea of a thermonuclear project, a new thermonuclear economy, that is the expression of liberty, freedom, and the pursuit of happiness for us today. And we are in such a situation that I do see, personally, that if we do not accept the shift, which is going back to the paradigm that was set forth by Kennedy, was intended by Kennedy, and really the whole leadership gang of that time, Bobby Kennedy, Malcolm X when he got better, Dr. King, and so forth, then I think we can lose it all. I think this country will not survive. And not only will this country not survive, but I don't see that any part of the planet will survive whatsoever. So, in presenting this work, we really investigate what is really the power of the human mind, and to understand what is the real true human identity and its purpose in existing in this place that we call the universe, or space as some people like to call it. So, with that said, let's start from some fundamentals here. Now, who has ever gone out and done stargazing, or just been in some place where it's dark and you see the stars and you notice?
Yeah.
Pretty much everybody?
Yeah.
Have you ever done it for a long period of time, or is it just a one-night thing? Yeah?
It was like over a weekend at camp up in the mountains.
Right,
When you get out of this area, the light blocks out a lot of stuff.
right.
So when you go up in the mountains and it's totally dark, I'll never forget the first night we were out there. Everybody said, "Oh my God, I didn't know there were that many stars."
Right. Well, we're going to learn today that they're ordered. And they're ordered based on the power of how the mind creates, how the mind constructs knowability. But to begin, let's just look at that thing called the sky. Now, this is not the real sky, but it's a virtual representation of it. Really. Don't let me brainwash you. Now, funny enough, the thing that I need is not here. Why? Okay. Well, we're going to do something here. We're going to look at Mars. We are right now looking at the sky as if you were at my hometown in Purcellville, Virginia. And that little thing there, people see that? Okay, sun's out, so you can't really see the stars or anything out there. But that's where Mars is.
And that's a live picture.
It's a virtual representation.
Okay.
But it's pretty accurate in terms of data and
That's
forecast.
what's going on right now.
Yeah, for example, if we were to go later into the night. Why isn't it? Let me do it faster. I'm gonna play God and turn off the sun. Okay. So, let me do this again. We're gonna follow planet Mars. And it's on the ground. I'm gonna play God
It's not
again.
the grass.
And command the ground to be gone. There. Okay, so just watch this for a second, right? E is east. That line that you see there, that's just, oh, you can't see it from here. So maybe we can see that pretty clearly. Do you know what you're looking at? Well, what I'm doing right now is you're seeing how Mars moves every single day.
That was the moon just passes by.
What's the bright light to the right of it?
That's the sun. I just virtually turned off the atmosphere so you can see all the stars, because that'll be crucial. But at least one thing that you notice from a first day observation is if you were to stare at the sky for about 2 hours, that's the idea of east and west, right? The sun rises on the east, everything rises in the east and settles in the west. And so from perception of sight, the sky is moving that way. Everything's just moving that way, right? But right now what we're doing is we're looking how Mars, if we're looking at the planet Mars every single day, right? Say it's sometime, there it says 12:51. So every day at 12:51, right? On the 23rd of April, the 26th of April, the 27th, so on and so forth. You guys get the picture? Right? You have this east to west, right, of the stars. But what does Mars look like it's actually doing? Or even the sun, in this case?
Looks like a star in a sense, but on the planet Venus.
No, not what it looks like, but in relation to, you see this the background, right?
Yeah.
Which side is the background moving?
Galaxy.
Right? Now, relative to, for example, this star, which direction is Mars moving?
The other way.
The other way. Yeah.
Right.
How come?
Yeah, interesting, huh?
So you say Mars is going in an opposite rotation than the rest of the planets?
No. You can actually see it just like if you were
Could you turn off the lights?
on the aircraft and you get that big aircraft moving 6 speed, except for you can see this just
Sort of, kind of like that, yeah. But the key thing is
We're viewing it from the Earth, which is also moving.
Yeah.
exactly,
It's almost likely the same.
exactly, right. And so, in a funny way, your sight played a little trick on you, but your mind animated something a little bit more truthful, right? And so that was a paradox that rested with people and, for astronomers for ages. And, not to get too much into it, but there's all sorts of theories, what's going on. These planets is the Greek word for wandering, if I'm not mistaken. So they call them planets. These are wandering stars. They're on their own, right? They're rebelling. And so anyhow, a lot of theories were attached to it that, okay, right, that's happening. So that's, these things are orbiting. What's at the center? Clearly the Earth's at the center, no, the sun's at the center. They have these things called epicycles, etc., I won't get into now. But they had all these sorts of crazy models to try to explain what was going on. Now, what Kepler did is, in his new astronomy, presents that not only is it incorrect to say that the planets revolve around the Earth, which is what the typical belief was, but that what they really orbit, all these planets, including the Earth, is the sun. And the hypothesis is the sun is a motive power. It's a different species in the planet. It's a cause. And that's what he searched for. And aside from that, which is what's going to be crucial for what we're going to investigate here, he also broke and proved that the planets, as was commonly believed, do not orbit in perfect circles.
Say that again.
They don't what?
The planets do not orbit in perfect circles.
Ellipse.
Yes, they are elliptical, which he proves in the new astronomy. Now, the thing that struck him, despite the fact that he discovered that, and he reveals this in the third section of the new astronomy, is the search for universal truth. What's the universal cause here? What's the hierarchy of organization, right? So he was looking for principle. And so, yes, he discovered that the planets orbit in elliptically around the sun, but that they're actually not all of the same type of ellipse. They're different. And let me show you. Use a quick example here. I actually meant to bring this out and I forgot. No, I don't want you. Excuse me. No. Oops. Let's see, sorry about that. Okay. See that okay? So that's the perfect circle system. They have other ones that are more complicated that I don't I think it'd be too much to get into right now. The elliptical orbits, right? Okay, now I have that. Now, immediately, you would say these two are ellipses. And what are these two? Okay. Now, just looking at this side, are they the same ellipse? They're different, right? Let's look back here. Now, these circles, the only difference between them is that one is bigger than the other, right? But they're still equidistant from the center. This, it's more than a difference than just size, structure, but it's still an ellipse because it has two foci points that create its curvature. Let me show you this other image. Okay, so these dots, people know how to form an ellipse. Use two foci points, right? Instead of like one, as opposed to circle, use two. You can draw a string around it. That's how you create it. So the ellipse here, that's longer, looks more like a surfboard. You see that their foci points are much more separated, right? These are closer together. That's just a circle, so it has one. And then here I have two little dots. Can you see the difference? One is bright yellow, and the other one's dark. I did that just to represent that there is a little foci. There is two foci here. This actually is also an ellipse, just an imperceptible one. Now, why am I showing you this? This is what he has to deal with. He doesn't have a planetary system where they all do this around the sun, or just this, but they do something like that, right? Particularly Venus and Earth, their orbits are more like this. What he calls this little thing here, the eccentricity, are very tiny. For Mercury, it's very large. For Saturn and Jupiter, it's kind of medium. Why? That's the question. Why? Is it just random? Is there some purpose? Well, in order to figure that out, the question is, what is it about how these things would organize, how the Creator would think, how God Himself would have constructed this, that I can understand it myself? And so his hypothesis really was a pretty ambitious one, you could say for the times, and I think even for today, which is how, if I were the creator of the universe, if I were God, how would I, being God, a rational, supreme being, create and want to construct a system, a planetary system? Is that a question that can actually be answered? In order to get to that, he had to, in a certain way, leave astronomy, so to speak, and get into the domain of mind. What is the human mind? How does the mind know? So let's just start from here. Everybody see that? Circle, right? Not that interesting. Okay. Now, can everybody see that? What are you looking at?
Geometrical shapes.
Yeah.
It's original shapes.
The what?
The original shapes, they all fit into a circle. Each point touches a circle perfectly.
Right. Yeah, exactly. They're equidistant, right?
4, 5, 6.
Right. So that's just a half, right? 3, 4. So these polygons, you've learned about them since you were kids. You know this. And now we're going to look at this in a different way. We're going to look at it in the way that he used them to understand something. Well, first off, these are constructive actions of the mind to create equal divisions of a circle, right? This is not something random. It's something that the mind tends to do. I intend to cut the circle in half. You probably literally couldn't do it in real life. You can approximate it, but the idea exists in your mind of what you're trying to accomplish, right? So that's what you did, even though it might be perfect, and what you actually do is perfect in terms of the state of mind that what you're trying to affect out of the mind as an idea. So you have the creation of these polygons as a result of that constructible action. Now, what he gets into in the beginning stages of that book, The Harmonies of the World, is that the mind could act, not only is it that you construct these things, but through also other forms of constructible actions, you can uncover the relationship of your whole, in this case, the division of the half, which is the first thing you would do. It's the first thing you would conceive of possibly doing. You can understand what that is in terms of length in relation to all these other polygons, their chords. He calls it knowability, right? That there's a knowability, degrees of knowability.
No.
And I am kind of brushing somewhat quick on this, but in the book he gets into a little bit more detail. So if you feel like some things are missing, that's okay. We can take it up in the Q&A. But that's the issue, right? Constructible actions of the mind. So you know what's this? That's a half, 3 equal parts, 4, 5, 6, and 8. Simple, you know that, easy. Now what he does is, that is a constructible action of my thoughts. And the thoughts precedes what happened in the actual thing that you're creating it in, the circle. So what if you were to do it somewhere else? Well, before that, you can just take a quick look at it. I put them all on top of each other, and those are just the proportions. 5/6 is 5 parts of a hexagon. 4/5 is 4 parts of a pentagon. Clear, right? So those let me just make that point clear. These are all these proportions that you've seen are related to those polygons, right? Those rational shapes. Now, you guys know what we're looking at here?
Use it with numbers.
Yeah, this thing is called a monochord. I have one over there, which I will bring in a second. And you might notice those proportions taken from the polygon, right? 5 equal parts of 6, 4 to 5, 3 equal parts of 4, which comes from the square. 2 equal parts of 3, which comes from what you're looking at here is those proportions that originated in the polygons now being applied to the divisions of a string. Now, getting away from the numbers, we're dealing with strings, we can do something interesting with them, which is hear what those proportions sound like. And I would like to do that very quickly. Experimentation. This is the real deal. This ain't virtual. Okay. So I am going to play that in order. We have the whole circle. Everyone can hear that okay? The whole circle. In other words, the note G. If you don't remember the notes, it's fine, doesn't matter. Now we're gonna play 5 parts of the hexagon. Now we're gonna play 4 parts of the pentagon. Three-fourths of the square. 2/3 of the triangle. 5 parts of the octagon. 3 parts again of the pentagon. And then finally, half of the circle.
It's like an octave.
Yeah, it is an octave.
Yeah.
Interesting, huh? The whole circle, half the circle. Now let me play you all those polygons a little quicker. So we have the whole circle. Right? That's what you call a scale in music. And just as a footnote, it's very interesting that even in the world of music, from what I understand and what he's attacking in his third book, where he takes this particular section up, even this rational constructions of an instrument were not heeded until after his time. But it shows you, right? There's something constructible in anything that we do, and it's knowable. So I call these the 7 harmonic divisions. Harmonic because, and this is where I'm going to need your help now. I need volunteers. I need you. I need, hey, Bruce. I need the lieutenant governor. I need you, and would you help me with this?
Sure.
I need you to hum sound for me. Okay, Bruce, you do the low one. They're off tune. All right, so we're doing choral practices. All right, how about this? Can you do that? Can you do the octave higher? Hold that. Hold that, and then I'll give you. Can you do that? Almost. All right. It's gonna be a little difficult. Well, do you know the basic idea of harmony? What it means? What does it mean?
Sorry, I used to know and I don't actually know. It's kind of multiple notes that sound good. I know that there's a technical definition. I'm sorry.
You got it. It's fine to say that. You want to say it loud so they can hear?
What? Say what?
What you said was fine.
Multiple notes that are simultaneously playing. They sound nice together, usually, but not. There's a technical definition, but I don't know it. I'm actually in chorus. But,
Oh, you are?
Yeah.
Okay.
But I'm just very bad at music theory. I don't know any of this stuff. I'm just good.
It's like different tones develop from the original tone, and it's similar. It's from the Fibonacci sequence, where the previous two, with the previous 2 numbers, they give you the third one, and it's the simplest sequence in the universe. So I don't know exactly how it works in music, but the sequence is you gain. It's you gain the third number from the first 2.
Mm-hmm. That's an interesting way of putting it.
Yeah, that's related to the golden ratio.
Yeah. That
Form
is.
of physical harmony.
Yeah. It'd be better to hear it. I wish I had more instruments or something. But, right, you have the coming together of supposedly 3 separate singularities that, without any prior knowledge or education, they are the combination of sounds that you would say you like. You would say, it sounds beautiful, I like that sound. As opposed to when you hear something like from, I don't know, Jason or Scary Movie or something. Those weird dissonances. let's see if we can try one. You want to help me?
I can give my best. I'm not-
Okay. Give me a G. Stay right there. You stay there. Now you wouldn't want to listen to that forever. That's what you call a dissonant. Dissonance, right? They're not consonant. Now let me do something more in the realm of harmonies. I really need 3 separate, but I think I get the point across. Give it the G again. No. A little different, right?
Yeah.
Okay. Or, I actually did bring a suitable example that I was going to show at the end, but this will come back up. Uh-oh. Looks like someone didn't pay their bills.
Step on one of the chords.
Did everything turn off? Is this still on? The sound?
Well, I think try it. I'll give a last.
Is the speakers off? They're turned off too? Uh-oh. I need that. Well, let's see if you can just hear it like this. Yeah, we'll have to do that. You might be able to hear this. Works, right?
Yeah.
What you heard were not that. What you heard was the whole, 4/5, and 6. Done in many octaves, of course. It's played across the piano, right?
Can we hear it again?
Yes, absolutely. Right. So that's what we call the harmony. There's other kinds, but let's stick with that one. Now the basic thing is the harmonies are singular moments. They're singular. Oh, I can't believe why I keep doing this. I don't like Photoshop. They are unique moments of construction. They're those moments that are created by the construction of a polygon that are the result of the mind. And they have an ordering to them in terms of which one is more noble than the other. Just in terms of just empirically looking at these, let me just go back to it. You would say that, you know, in comparison to a half, right? If I told you to construct the octagon and a half, which one would you do first? Right? To do the octagon, you'd need to go to Starbucks, get a coffee, and work on it for a living, right?
Well, the half seems like it gives you a basis for creating the octagon, or it would actually organize in an easier way the construction of the octagon if you did that first.
Right. Yeah, I think that's true. Great.
It's also the more, like, it can go on infinitely, the amount of sides that you can make of a shape.
Yes.
And the more you do it, the closer it gets to the circle. And it'll just keep getting closer without touching it, but that's also the golden ratio. The closer and closer it gets. And it takes up more and more space within the circle without getting to 100%.
Yeah. It's actually interesting.
Well, in a way, with the musical tones that harmonize, you could think of it like people that are friendly with each other, you know, that harmonize with each other. Whereas if you have discord, atonal, you know, tones that don't harmonize, you could think of like people that are unfriendly toward each other. You know, that they don't, they're not cordial with each other. They don't have to come to physical violence, to blows, but they're not friendly with each other.
Eugene, do you remember what Diane Sayre said about what she's going to do if she gets into the Congress? This was when she was running for Congress.
Oh, yeah.
She said she was going to take the Congress and turn them into one big chorus and give them and conduct them
Good.
so that they could be in harmony.
Yeah, but I'm just trying to make out a point. It's like tones that are friendly toward each other, that harmonize with each other. Whereas atonal or discord is tones that don't harmonize to each other. It's like people that are unfriendly toward each other. They don't have to come to physical blows, but they're not harmonizing.
The difference here, though, now that we're going to press on and get to the next stage, which will be the final stage here, is these sounds are not just something that you do receive with pleasure in terms of your sensation, but from what we looked at with the polygons, you know why they are beautiful.
I think in a way, maybe what Eugene is saying, right, is like, you know that these sounds are lawful, because maybe you can just say, well, aesthetically in your ears, you know, or to your hearing, they sound that, you know, they sound like they have some kind of consonant, some kind of complement, the term harmony. But then also what Eugene's saying, you know, and what Daniel brought up, you know, people working together, people who are functioning in a way that's cohesive with one another. Well, in the lawful universe, that's how you get things done. That's how you move forward. That's how you develop greater ideas, higher movements of principle. So there is kind of a correspondence between, right, what you're doing here and the actual functioning of people, of organization, of universal motion. The two are not dissimilar.
Yeah. Yeah. What I'm trying to concentrate on is that they're not just sounds that you just lie in the grass and you just enjoy, though it's true and it's fine. But more powerful than that, right? Because an animal can enjoy harmony. But the animal cannot know why it is harmonic. And as simple and as easy as it was, and you learned it back when you were 2 years old, the polygons, you look back at it in a different way, with a different lens, and you start to realize something about the nature of how the mind works. Now, going back into the solar system, that's what we're looking for. Asking you to be an archaeologist in the way that we can find evidence of past civilizations as they do to detect civilizations that lived thousands of years, right, 2,000 years ago, like they do in Peru and a lot of these other South American places, Central America, Mexico, Egypt. We're also now saying, well, what are the fossils of a mind in the universe? And one thing that we learned from the divisions of the harmonic scale is these are the reflections of a mind. Can I find these constructible proportions in any way or fashion in the structure of the solar system that we're investigating, our solar system that we live in? So that's the task. And the answer is an interesting one. Now, here, this is a really bad diagram of 1 degree. And I didn't realize it until afterwards, but I'm going to do this setup so you understand what I do next and to understand what he actually does. So this is 1 degree, right? 60 minutes, just to be brief, 60 minutes in seconds in terms of angles, they're just fractions of a degree. You imagine how large 1 degree is, it's not very much. So if you take a minute of that, that's a lot more, not very much. And if you take a second of the minute, that's even less. So that's just what that is to be, just to have that understood. So that's just a representation of a degree. It's really bad, sorry. Now, what I want to do, okay. Do people understand this chart? It's pretty self-evident. You want to say what it is?
So it's well, they correspond. It's like a ratio. It's wait, what do you want me to say? Sorry.
You should, if you can explain what this chart is.
What the chart kind
Yeah.
of shows. Well, the string, like with musical instrument, right? Like the chord. Or, wait, like
Well,
yeah, like the first one is wait, sorry, never mind. I think I kind of lost myself. But
On the left side, the measurement of the degrees and minutes, and how many degrees is it on the right side? So 60 minutes, 1 degree, and all the way to about 30 minutes, a half degree.
People understand what I said? So, right, clearly what's underneath this is angles, this is the string. We've done this, so you know what this is, you know what that sounds like, and I gave you that example in the sound example, right? These are just, these proportions transposed in the domain of angles. So 30 seconds is half of 60 minutes. In other words, what he was saying, it's half of a degree.
Wait, I'm sorry, 30 minutes is half of 60 minutes.
You know what? I'm sorry. I missed it. This symbol is incorrect. It should only be 1 dash. That's supposed to be the minutes. It's supposed to be seconds. Yeah, right. So, yeah, 60 minutes, right, is 1 degree. 30 minutes, it's half of 60, which is up, right? Exactly, half a degree. 36 minutes is 3/5 of a degree. 40, 2/3, 45, 3/4, etc.
so yeah, it's a ratio.
Yes. So now we've created these rational ratios, these ratios that are unique to the mind in angles. Why does that matter to us? The theme that he rested on throughout his work in discovering what are the true orbits of the planets was the sun. This thing called the sun. We shouldn't ignore it. You can't, because it's the cause of motion. In this, or you could say in the world of sound, right? We receive the harmonic proportions. The beauty, we did it, right? We constructed, and we also receive it. So if I constructed this and you knew nothing about it, you could still receive the beautiful sounds and whatever you do with it, right? Okay. So you're the thing that can sense the harmony. You can receive it. But what's going to receive the harmony in something like the solar system? It's not you. So he goes back to his hypothesis of the sun. That if there's any way that these harmonies would exist in our solar system, they would do so in according to the sun. The sun would be the sensory organ, so to speak, that would receive it. So what's unique about it? Well, since the sun, does its causes its orbits, we want to know where in the orbits does it happen. Now, go back to the ellipse. Put the ellipse back in your mind that I showed you earlier. Now, in the actual system, there is no two suns. There's no two foci, right? There's only one, and that one foci is the sun. And so you can imagine that if these things orbit around it in an ellipse, there's a moment where the planet is closest to the sun, right, and furthest away. That is called aphelion, furthest, perihelion, closest, respectively. Now that matters to us because what is it? Well, they're the maximum and minimum moments of these orbits. they're all that can be. And the sun clearly is arranging these planets to go no more and no less. And so after, some going through where it could possibly exist, he locates and says, if I were to create harmonies, where the sensible place to create them in the system would be at the extreme motions of the planets. That's where the sun would form these rational proportions. That is a matter of angular velocity, how the sun sees it move. So in this X image, I put this guy here, there, proportions you know and you heard.
Kepler covers all this in the new discovery, right?
Huh?
Kepler covers all this in his new discovery article, correct?
New astronomy, you mean?
And new astronomy, sorry.
The astronomy and the harmonies. This one particularly. But yeah, the orbits and the astronomy. Okay. So here you have these numbers that you've never seen before, right? All they are angles. Now, what I've done is I've taken this angle, and I'll explain where I got this from in a second. And I said, okay, now I'm going to transpose angles to how we create a musical scale. If I were to do that, that's what you would have, right? So 3 minutes, 33 seconds is half of 1 minute, 47 seconds, likewise. And all those are what they relate to respectively. Now, what those angles are the angles that those planets that you see right above create at the extreme motions from the sun.
What does that mean, that the angle is 147 for Saturn? What does that mean?
It means that where Saturn is at its furthest distance from the sun, and these are all derived from the time of interval of a day. So how the sun sees a planet move in a day.
Oh.
So when Saturn, and there's some planets missing, that's fine, we can explain it later. When Saturn is furthest away from the sun, aphelion, and if the sun were to watch how Saturn moves in a day, it moves 1 minute and 47 seconds of an angle.
So there's 360 degrees, and every degree has 60 minutes in it.
Yes.
So Saturn moves just a tiny fraction of 1 minute of 1/60th of 1 degree in the course of one Earth day.
Yes.
I see.
Yes.
And why are they twice? Why there's two Jupiters?
Because one is aphelion and one is perihelion.
Oh, I see.
So there's Jupiter does two motions where it does correspond with the scale. Now, what I did here, you remember what this woman said about the octave? We heard the low sound, and then we heard his twin brother, right, half the size. That's what I did with these. These numbers in reality would be larger for Jupiter and the rest, except this is correct. But I just tuned them down octaves so that they represent the same note. Just the way that you do here. So in terms of value and note, they are the same thing. Pitch, it's a different story. But in terms of note, you see the correspondence? 2 seconds away from where 4/5 actually is, the note B. That's not much. So on and so forth. Venus is interesting because 3/5 is 2 minutes, 58 seconds of a degree. Venus is exactly 2 minutes and 58 seconds of a degree. That's what the sun sees it do. I forget if that's the perihelion or aphelion. Now you can create another scale, and this is interesting because Saturn, right? Saturn has two extremes, just like every other planet. And if I were to take Saturn's position where it's closest to the sun, perihelion, you'd form another scale. And that scale would actually be something that is more related to what you call the minor scale. This scale, where you take these proportions starting from Saturn's furthest position from the sun, forms a scale that is much more conducive to the major scale, or the happy scale, some people call it, right?
And in that major scale, Earth is an octave away from Saturn in terms of this.
Yes.
That's it.
In real life, Earth is actually 5 octaves above.
Right.
But yeah, same thing. Right. Okay. So that's just interesting. Now here, this is what will conclude the presentation and the point of this. I said from the very beginning that I would show you how the planetary system expresses rational thought. Rational thought is more than just a constructive scale, it's actually the ability to form a harmony. And if they can form a harmony, then it reveals to us what the nature of the coherence is of the planets to the sun, and reveals something about the personality of the sun. So the issue is, away from just creating nodes, can the 6 planets orbit the sun in such a similar manner as you create the harmonic scales in the monochord or any divisions of any instrument, right? And if you remember the quick example Daniel helped me do earlier, there's some notes that are notes, but they don't sound really good together. There's some that do. And that's what we want to find. So, looking back at, well, let's just look at this, right? Now you see those numbers up there? Those are the actual angles. Now I've tuned them back. I put them back to their appropriate octaves. Right up. Don't worry if you don't know about how many, as long as you understand the idea. So the top is furthest, the bottom is the closest. Naturally, it should be more, because when it's closer to the sun, it's closer to the power of the sun, and so the planets consequently move faster than when they're further away, which is the result of the proportions. Right? Down here, I again just put that. Now, that, you all recognize, because we've seen it repeatedly. Right? 4/5, 5/6, 2/3. In other words, right? These, which we won't get into, these are what are called melodic intervals. They basically are the relationship between two, like 24, 25ths. It's the difference between the major and the minor third and the major and the minor sixth. So in other words, this. Heard that scale? That's the minor. Major. So this proportion, which is what this is approximately, Venus's orbit, forms the difference between a major and a minor scale. Okay, that's just what that is. 15/16 is just this, it's not the difference, but it's just the difference between something like this, moving from one to the other. Not technically harmonic, but they are notes, and it's the relationship between the two. 5/12, what that is, it's 2 octaves above and a minor third. So you can imagine going like this, the next octave, and then the equivalent of 5/6. Okay, now my purpose in doing that is we now know what the proportions are between a planet's own orbits. And what I show you here is that these angular measurements, the measurements of these planets respectively from the sun at the extreme motions, they approximate these proportions. Actually, for one of them, they're just a few seconds off, which is not a big deal. It's not even a minute, it's really that large. So a few seconds is it's practically imperceptible. And going back to this figure, you know that all these planets have a specific note value to them. So what I want to do, and that's what the note values are taken from when we transpose them to the musical scale. Everybody see that? Pretty self-explanatory, right? Saturn was our first. That's just simply because it's the furthest away. So it's our G, that's where it was on the scale. Jupiter was at B. These being the furthest distances. Mars was at F sharp. Earth was at the octave G. Venus is at E. And Mercury represented the note A. So if we want to take we can know from that, and given what their proportions are, what then their notes are at their other extreme, right? The closest. Which is that? 4/5 is a major third, right? That's Jupiter. Saturn, excuse me. Jupiter, 5/6, is the minor third. Saturn is the 5th. Earth is what's called in music semitone, which is this. Venus, as we said before, is what's called a diesis, or the difference between a major and a minor scale. And then Mercury is 2 octaves and a minor third. Right? Okay. Now, to just wrap this up, the point of this was to seek a universal harmonic relation between all 6 planets. Now, what we see with Earth and Venus is that they don't really form much of anything. And so we want to see how the other 4 planets can form harmonies compatible so that Earth and Venus can partake. And we know that, well, Earth has G. The note E is what's called the major 6. So we need one more note to harmonize with that. And there are 2 possibilities. There's the note C. Heard that? And there's also the note B. It is, sort of. I know what you're saying, though, but I know what you're saying. Anyhow, so we want to look for those instances where we would find C, the relationship of G, C, and E, or G, B, and E. Now, if we look at Mars, it goes from G to B. Saturn. I don't like this guy, apparently. I don't call him by his name. G to B, right? So let's start there. Let's start with the idea of B. We'll work together on this one, so I'll make sure we all understand it. So we need a B and a G. So G, E, and B are allowed. Okay? Now, this planet happens to have both of them in there. Great. Wonderful. So Here we have a harmonic relationship between this, this, and that. So now 3 are included. What about Jupiter? We do have a B. Right? Easy. Now, in Mars, we technically do not have those notes anywhere in the extremes, but its interval is from an F sharp to a C, which means that what's contained within its orbit?
A G? A B?
Yes. Can you tell them why?
No.
Did people hear what he said?
I said there's a G and a B.
Do people see that?
You mean in between the two notes?
Yeah.
Yeah.
Well, you
Because
say it's
after
going
F sharp
from C to F sharp?
Yeah, this is what it does roughly in its own orbit from the furthest to the closest position of the sun.
Okay.
But it's an orbit. It has to get there.
All right.
So it goes through those notes.
Right. Just the way you have to get from your whole note to your half.
Okay, that's it.
Like
It's
scale.
traversing
Yes.
its elliptical course around the sun, you're saying?
Yes.
So it travels through G to, okay, from G to B to C, okay.
Okay.
Right? People see that? It's contained within there.
Yeah.
So not in its extreme orbits, but within its orbit, Mars has the ability to harmonize with Jupiter, Saturn, Earth, and Venus in 2 ways. Well, at least in one way, right? The G is there and the B. So what's left is Mercury, which is pretty easy.
Because that's the closest to the sun?
Well, because its orbit is an interval of 2 octaves and a minor third.
So it contains at least two iterances of each of them.
Right. I think really about 5 instances of the G and the B.
Okay, yeah.
Right, because the space is so wide, so it contains it, right? Because it goes 1 full octave, then it goes another octave,
Right.
and then,
Okay.
so they occur many times in there. In other words, what occurs between, what we just showed occurs physically is this. We just uncovered what we heard, how that exists in the orbits of all 6 planets.
Now, I have one question. Why are you saying 6 planets?
Because we're studying the 6, Mercury to Jupiter.
Because like you always taught in school that they were 9.
There are more, yeah.
But that's what Kepler
Yeah, I'm
knew.
not pushing it.
Kepler only knew 6 planets.
Oh, okay.
Yeah, at that time.
Yeah.
Yeah, they only had 6. They only knew of 6.
Yeah.
Right. I am not promoting that none others exist. But in terms of those that were at least visible to us at those times, right?
All right. I got you.
So that's what that does. Anyhow, I can take questions.
Yeah, I left to get a cup of coffee because I was falling asleep.
Okay.
In the mid-90s, when I first began going to the conferences and really listening to Lynn, I would last anywhere from a half hour and after 4 hours before I would fall asleep, because my mind just couldn't get around the things that Lynn was putting out.
Right.
Well, I've improved. But the work that's been done here is not anything that I can take home and work on my own. When I try to go to the videos in the classes, I don't know what happened to me, but I really have trouble with this stuff. And of course, like a muscle, if you don't work it, you lose it. So I know that that's a factor in it. and it's almost really not directly at you, but a plea in general that, and I know it's not easy to do, but we can't have our own basement team. But the only way, at least I don't think so at this point, but the only way I could really understand this, because I have gap, again, it's just very difficult for me. Only it seems to me in its simplest forms, and then something happens and I'm lost. Is that if we could organize something where over a period of time we did some work around this stuff that's more intensive, where I could stop a person in the middle and whatever it is, because I tend to think I'm not alone in this. Gee, I'm not even going to master it. I would just like to feel confident in it. And I really do have trouble with it, so.
There's just not a culture. I think the real conflict, there's not a real culture that's committed to this kind of work. I mean, I know what you're saying. It takes an intense level of concentration. Even for myself personally, to work through this, it took a lot of concentration and a lot of fighting to make the time to do it. Because it seems, on the surface level, very impractical. That famous word. You shouldn't do it. We got to stop the bad guys. But, I mean, I think part of what could help, one, really just orient the mind to even devote yourself to figure out how to make it happen, how to work through it if it's possible. I'm not saying that it is in all cases. Is you just have to really know what the fight's about. I mean, to me, this is about, I brought up the example of Deborah in the beginning. Well, because, if you look at it in the real way, it's just it's a story about the struggle of mankind to be free. Right? That's what it is. The oppression of Pharaoh was to be free. To have Deborah come in and fight the Canaanites after they've been oppressed because of their own stupidity. What? Freedom. Despite the fact that they were stupid and gave their ways to ideological beliefs that drove them away from understanding how to harness the power of the universe, which is what we're fighting for in fusion. Right? Still, you're human. You should be free. There should be a faction, there should be a leadership faction to fight to free people's freedom. Today, for me, at least to make this clear, it is about that. To me, this is about freedom. It's about the real meaning of justice. I've seen so many people go out there and scream, liberty, my Constitution, but you don't know what in the God's earth you're talking about. What do you propose to do with this species that's going to live for many generations? Not just you, not just whether you're going to pay for your taxes and your rent. Fine, sure, you should have that. Everyone should have access to bread, water, electricity, and the basic needs of life, absolutely. But we're not the dog. We're not the platypus. We're not the hippopotamus. We're not an alligator. We're not a fox. We're not an eagle. We're not a sheep. We're human. And that's different. Those creatures live off the land, and they live off for themselves, and at the most might take care of their immediate progeny. We have the power to take care of a civilization thousands of years into the future. It's a total difference. My contention with this society is that they don't think that way. But rather than getting enraged and saying you're bad, you deserve what you get, bye, I'm gonna go play my PlayStation or whatever kids do nowadays. I might be out of date, maybe Android, mobile devices. Why? And it's because there's no conviction in people for what is the identity of man. What if you did have a society where it was commonplace to talk about what I just presented? And it wasn't just something that some Latino kid from Los Angeles came out here to do and has about 2 people to talk to about this in depth. What if that was the society? And the society was conscious that the mind of the Creator is their power. Now, one thing I did not say that I would add here, here's another interesting thing to think about. We've talked about fusion, thermonuclear economy, etc. Well, let's look at it in a poetic way. We just went through how the nature of the sun is to express rational coherence of these bodies we call planets. What's the power of that thing? The fusion of hydrogen atoms. That thing that expresses what the mind can do in polygons and in music, its very source of power is fusion.
I was gonna say Venus is the only planet in our solar system in which the sun rises in the west and sets in the east. Not like all the other planets, because scientists believe that many have been hit by another body many millions of years ago, which caused it to rotate in the opposite direction.
Eugene?
On Venus, the sun rises in the west and sets in the east.
May I ask the following? Is it possible we could postpone that until afterwards? Because in the sense of, we've got about 15 minutes left, and I don't mean to cut off the Q&A, but we do need to get to, let's talk about that afterwards. Thank you, Hector. Thank you.
So, let me do this again. We're going to follow planet Mars, and it's on the ground. And play God
It's not
again,
the grass.
and command the ground to be gone. There. Okay, so just watch this for a second, right? E is east. That line that you see there, that's just, oh, you can't see it from here. Some people can see that pretty clearly. Do you know what you're looking at? Well, what I'm doing right now is you're seeing how Mars moves every single day.
That was the moon just passes by.
What's the bright light to the right of it?
That's the sun. I just virtually turned off the atmosphere so you can see all the stars, because that'll be crucial. But at least one thing that you notice from a first day observation is if you were to stare at the sky for about 2 hours, that's the idea of east and west, right? The sun rises on the east, everything rises in the east and settles in the west. And so from perception of sight, the sky is moving that way. Everything's just moving that way, right? But right now what we're doing is we're looking how Mars, if we're looking at the planet Mars every single day, right? Say it's sometime, there it says 12:51. So every day at 12:51, right? On the 23rd of April, the 26th of April, the 27th, so on and so forth. You guys get the picture? Right? You have this east to west, right, of the stars. But what does Mars look like it's actually doing? Or even the sun, in this case?
Looks like a star in a sense, but on the planet.
My object in this presentation is to show how the 6 planets that orbit around the sun, from Mercury to Saturn, are an expression of rational thought. Now, before I continue, let me just justify the politics of this work. There's a story that I like in particular from the book of Judges in the Old Testament. And it's the story of Deborah the prophetess. And if you're not familiar with, this is a time, generations after Moses and Joshua brought people from the bondage of Egypt into the so-called promised land of the Canaanites, where they were free and independent. But consistently, they continue to fall under oppression by kings, other types of savages, barbarianism, and so forth. And there's no separation of economic oppression from any form of oppression. It's precisely that. It's slavery, exploitation, exploitation of man, exploitation of resources and materials. And so, you know, Deborah is a prophetess who leads a war to allow the freedom of the people. I guess Israel in this case is not the crazy Israels of today, but then, as it was back then. Now, she says something very interesting that I think is important to reflect on. And as she's giving her sermon or her speech after they defeated the king of Canaanite that oppressed the Israeli people, which happened in numbers of times that you'll read if you ever get a chance to read this particular book. She mentions that the stars waged war from the heavens, and that was on the side of mankind. Now that's interesting as a poetic idea, but then also juxtapose the other point that I was saying, which is why, after they had this from some fundamentals here. Now, who has ever gone out and done stargazing or just been in some place where it's dark and you see the stars and you notice?
Yeah.
Yeah.
Pretty much everybody?
Yeah.
Have you ever done it for a long period of time, or is it just a one-night thing? Yeah?
It was like over a weekend at camp up in the mountains.
Right,
When you get out of this area, the light blocks out a lot of stuff.
right.
So when you go up in the mountains and it's totally dark, I'll never forget the first night we were out there. Everybody said, "Oh my God, I didn't know there were that many stars."
Right. Well, we're going to learn today that they're ordered. And they're ordered based on the power of how the mind creates, how the mind constructs knowability. But to begin, let's just look at that thing called the sky. Now, this is not the real sky, but it's a virtual representation of it. Really. Don't let me brainwash you. Now, funny enough, the thing that I need is not here. Why? Okay. Well, we're going to do something here. We're going to look at Mars. We are right now looking at the sky as if you were at my hometown in Purcellville, Virginia. And that little thing there, people see that? Okay, sun's out, so you can't really see the stars or anything out there. But that's where Mars is.
And that's a live picture.
It's a virtual representation.
Okay.
But it's pretty accurate in terms of data and
That's
forecast.
what's going on right now.
Yeah. For example, if we were to go later into the night. Why isn't it? Let me do it faster. I'm gonna play God and turn off the sun. Okay. And then we can wonder about something out there, even though we don't know it in detail. Just that. What creature on planet Earth can do that? Wonder, question, why? What is it? And it's the desire, it's that very question that burns in people like a passion, and to pursue discovery. And it's been to the extent that civilization had been committed to that personality themselves, which is innate, it's inherent, that we succeeded. In the United States, what made us the pinnacle of hope was not just some vague reference of liberty or some ambiguous idea of freedom, but that freedom was, as it states in the Declaration of Independence, right? The inalienable right to life, liberty, and the pursuit of happiness. And it's committed to that idea that you know what in modern ages, how that is expressed. And clearly what we're saying today about Glass-Steagall, the idea of a thermonuclear project, a new thermonuclear economy, that is the expression of liberty, freedom, and the pursuit of happiness for us today. And we are in such a situation that I do see, personally, that if we do not accept the shift, which is going back to the paradigm that was set forth by Kennedy, was intended by Kennedy, and really the whole leadership gang of that time, Bobby Kennedy, Malcolm X when he got better, Dr. King, and so forth, then I think we can lose it all. I think this country will not survive. And not only will this country not survive, but I don't see that any part of the planet will survive whatsoever. So, in presenting this work, we really investigate what is really the power of the human mind, and to understand what is the real true human identity and its purpose in existing in this place that we call the universe, or space as some people like to call it. So, with that said, let's start so-called right in the story. The hand of God brought them out of the bondage of Egypt, away from the oppression of Pharaoh. Why did these people consistently fall under more oppression? Generation after generation after generation after generation. And you know, I read that first maybe about 8 years ago, and it always hit my mind as a dissonance. And it wasn't only until recently that it really hit me the great insight that anybody can get from this. And it's that the source of corruption, the source of the oppressors, the power to oppress, the source is from the corruption of the people themselves. It's when the people don't pursue their actual creative powers. And the power of creativity, the power of the imagination, is the power to define the future. It's not just, yes, the forecast of future. You can see conditions where it would lead to if we continue on a certain trajectory, a certain pathway. But the real power of mankind is to envision in his mind, in the matter of his mind, before it actually exists in the actual world, what world he wants, what world he wishes to create. And that, I think, really turns into what I want to highlight with the importance of this work. Because it may seem as it belongs nowhere in the domain of politics. And I argue it indeed belongs everywhere in the domain of politics. And it's because we have a generation currently that does not just the specific work, but the intention to drive for what is man in the universe. That big black thing with the white dots outside that you see out there. You tell me you don't wonder about what's out there? You tell me you don't wonder about what is this massive ocean that we call space? And here we are, these little beings in terms of size and material, and we are here, and we brought fire, and we domesticated the beasts, right? We learned how to harvest crops greater than nature itself can do.